Hey guys, welcome to another YouTube video. In today's video, we'll be solving and explaining Leetcode problem number 22, Generate Parenthesis. This is one of those problems that may seem hard and difficult at first, but I'll be showing you some tips and tricks to help you understand and solve not only these problems, but problems that have a similar structure to this one as well. Let's get started. The first step in solving any programming problem is to read and understand the question. The problem statement reads, given n pairs of parentheses, write a function to generate all combination of well-formed parentheses. The examples given are n equals to 3. Well, all the possible well-formed parentheses for n is equals to 3, that is given n pairs of parentheses, is the output here in a list. The second example is for n is equals to 1. Given one pair of parentheses, all possible formed combinations of that one pair is the output that is given here in the list. Seeing this problem, the first thing that comes to mind is to generate all possible combinations and then figure out if a combination is valid or not. If it is valid, then we add it to a list and keep moving. The problem with this approach is that it'll take n factorial time. While this is not the best approach, it is important that you mention this to your interviewer so they have an idea of what is going through your mind and going through your thought process. As I said earlier, the problem with this approach is that it'll take n factorial time to generate all the possible combinations. Then it'll then take further work to figure out if a combination is valid or not. We can build on this approach by trying to figure out ways that we can reduce the time and the work complexity that we can do as we're building the possible combinations. One way we can do this will be to only generate valid combinations. Let's take a look at an example where we generate all possible combinations for n is equals to 1. So for n is equals to 1, the possible combinations we have are this and this. Well, just looking at this, I can automatically see that this is not a valid combination because it starts with a closing parenthesis. There is no way we can start a combination with a closing parenthesis and expect it to be a valid combination in the beginning. So one rule we can apply is we can only start a combination with an opening parenthesis. While generating all the possible combinations, we can apply specific rules to make sure that we do not generate invalid combinations. As stated earlier, one rule we can apply is that we can only start a combination with an opening parenthesis because starting a combination with a closed parenthesis will always lead to an invalid combination. Another rule we can apply is at any point in time, we can do two things. We can either open a parenthesis or we can close a parenthesis. We can open a parenthesis when the number of open parentheses we currently have for a valid combination is less than n. So the first rule is we can open when number of opened is less than n. The second rule that we can use to make sure we only generate valid combinations is we can only use a closing parenthesis when the number of open parentheses for a specific combination is greater than the number of closed parentheses. So we can only use closed when the number of opened is greater than the number of closed. Let me explain this further. Let's take an example where n is equals to 2. While generating all possible combinations, we can come across a combination that looks like this. To avoid this combination, we can only apply this closing brackets when the number of open brackets that we have, in this case, only here, is greater than the number of closed that we've applied. So in this case, the number of opened is equals to 1. But when we apply this bracket, the number of closed is also equals to 1. If we use the rule where the number of open must be greater than the number of closed that we currently have, then we would have never applied this bracket to even begin with. So, explaining that one more time, when we're at a situation like this, we can only apply a closed when we have enough open brackets to account for the closed bracket that we're about to apply. This will help us generate only valid combinations. Let's take a look at how the call stack will look for n is equals to 1. Well, for n is equals to 1, at the beginning, we have 0 open brackets and 0 closed brackets. We can only start a valid combination with an opening bracket. So when we apply our first opening bracket, we have 1 opening bracket and 0 closed bracket. Well, at this point in time, we can do two things. As I said earlier, we can either apply an opening or a closing. We can apply an opening when we have more opening brackets to use. So when the number of opening brackets we've used so far is less than n. In this case, n is equals to 1 and we've already used one closing bracket, so we can't apply any more closing brackets. The only thing we can do now is to apply a closing bracket. Why? Because the number of open bracket, which is 1, is greater than the number of closed bracket, which is 0. So we can then go further down and apply a closing bracket so that the number of open bracket is 1 and the number of closed bracket is 1 as well. When the number of open brackets and the number of closed brackets are equal to n, then we know we have one possible combination and we can stop building at that point in time. For the case of n is equals to 1, this is the only possible combination that we can have. Let's take a look at a different case for when n is equals to 2. Well, when n is equals to 2, at the beginning, we have 0 opening brackets and 0 closing brackets. The first thing we do using our rules is a valid combination must start with an opening bracket. So we have an opening bracket of 1 and a closing bracket of 0. Well, at this point in time, we can do two things. We can either use an opening bracket or we can use a closing bracket. The rule for using an opening bracket is we can only use it when we have enough to use. So when the number of opening brackets at that point in time is less than n. In this case, the number of opening brackets we have is 1 and 1 is less than 2. So yes, we can use an opening bracket. Now that we're at this point in the recursion call, we can do two things again. We can either use an opening or we can use a closing. We can only use an opening when the number of open brackets we've used at that point in time is less than n. In this case, 2 is not less than 2, so we can't use an opening anymore. Well, can we use a closing? Well, is the number of closed brackets less than the number of open brackets at that point in time? Yes, 0 is less than 2. So we can use a closed bracket. At this point in time, again, we can do two things. We can either use an opening or a closing. But as we have seen earlier, the number of openings is equal to the number of brackets that we have to use, which is n, so we can't use an opening. Can we use a closing? Yes. The number of open brackets is greater than the number of closed brackets, so we can use a closing bracket. Now that the number of openings and the number of closing is equal to n, we know that this is one possible combination. Going back to our recursion tree at the beginning where we chose to use another open bracket, we can go back and then use a closing bracket. Again, we have two options. We can use one or the other or both. Now, if we choose to close, well, we can only close when the number of opened is greater than the number of closed. So in this case, the number of opened is 1 and the number of closed is 0. So yes, we can close. We would have this. Opening is equals to 1 and closing is equals to 1. The next thing we can do at this point in time is to look, what can we do? Well, we can either open or close. To open, the number of open brackets we've used has to be less than the number of n, which is the number of total openings that we can use. But let's take a look at an example here. If we were to close, then we would have a scenario that looks like this. And this would violate our rule because there's no way this would be a valid combination. To avoid this, well, the number of opened, well, rather, to use a close, the number of opened must be greater than the number of closed. And in this case, 1 is not greater than 1. That's why we can't use a closing bracket in this case. Going back to the tree, well, we can use an opening because the number of openings is less than n. So we have this. Well, we can't use any openings because the number of openings is now equals to n. But can we use a closing? Yes, because the number of opened is greater than the number of closed. So we can then do this. And this would be the two possible combinations for n is equals to 2. We have them right here and right here. Let's take a look at an even bigger example for when n is equals to 3. Looking at our example for n is equals to 3, like the previous cases, we start with open is equals to 0 and closing is equals to 0. Well, the first thing we stated earlier is we can only start a valid combination with an opening parenthesis. In this case, opening is now 1 and closing is now 0. At each point in time, we can do two things. We can either open or we can either close. Let's say we open. Well, to open, the number of open that we currently have to be less than n. 1 is less than n, which is 3. So we can use an opening. Now, at this point in time, we can choose to do another two things. We can either open or we can then close. Let's choose to open again since the number of open that we have is less than n. Now that the number of opening that we have is equals to n, we can't open anymore. However, what we can do is we can close. Number of open that we currently have is greater than the number of closed that we currently have. 3 is greater than 0. So we can then close. Again, similar to what we have in the past, we can either open or we can close. But we can't open because we already used up all our open brackets. The only thing we can do is close. So we'll have and finally, we can only close because the number of opening that we have is greater than the number of closed, and we can't open anymore because the number of openings that we have is equals to n. Now let's go back in our recursion stack and choose a different approach. Rather, choose a different path. So where we chose to open, now we'll close. Well, let's go back up here. When we're up here, we chose to open another bracket, but in actuality, we could have closed as well. If we closed, it would look like this. At this point in time, we can also do two things. We can either choose to open or we can choose to close. Well, the question we should ask ourselves is, can we close? From our rules, we can only close when the number of opened is greater than the number of closed. Well, the number of open in this case is 2 and the number of closed is 1. So we can choose to close as well. Now, at this point in time, we can choose to do two things. We can either open or we can close. But if we take a look at our rules, we can't close anymore because the number of opened is not greater than the number of closed. Meaning that at this point, we can only do one thing, we can open. Close is equals to 2, open is equals to 3. Now, we can't open anymore because we've used all our opens, but we can close because the number of open is greater than the number of closed. Now, if we go back again to the top of the tree, we can pick a point where we open, but rather than opening, we can choose to go down another path where we closed. Let's pick this path, for example. If we were to go down this way and we closed, we would have this, where we have open is equals to 1 and closing equals to 1. Well, at this point in time, we can either open or close again. Let's choose to open. We'll have, this would be closing is equals to 1. We would have well, we can choose to either open or close. Let's choose to close. We would have this. Opening is equals to 2 and closing is equals to 2. Well, at this point in time, we can't close anymore because the number of closing is less than the number of opened. And to close, we must have opened a bracket in the past that we can use to account for the closed brackets we're about to add. So we can only use an opening at this point in time, excuse me. So this would lead to this, where we have opening equals to 3 and closing is equals to 3. Going back to a previous path where we chose to do another opening, we could have closed as well. So let's go back to here. Well, here we could have also opened another one. If we opened here, we would have had this. And this will eventually lead to a path that goes like this, where we have opening equals to 3 and closing is equals to 3. We can then pick another path where we chose to close rather than open, or another path where we chose to open rather than close. Let's look at this path, for example. We could have opened here and then closed again, and this would give us another valid combination. So the summary is, as you're building the tree and as you're going down, you can choose to either open or close. This is all the possible combinations for n is equals to 3. From the previous example, we had 1, 2, 3, 4, 5. Looking at the tree that we've built by either choosing to open or close using our specific rules, we have 1, 2, 3, 4, 5. The tricky part with this problem is understanding that it's a backtracking algorithm where at one point in time, you have two decisions to make. You can either make the first one, then go down the tree and figure out all possible paths that may occur for making that decision, but knowing that you'll eventually come back up and potentially make a second decision if the rules that you've applied work, or if the rules that you've applied would make you to go that decision. Turning this into code, we need to keep track of two variables: the number of opening brackets and the number of closing brackets that we've used. We can then apply our rules to make sure that we're only opening or closing a bracket when we have to, and we need to keep track of these variables so that when they're equal to n, we know that we have created a possible scenario and add that to our list. Let's take a look at the code. Hey guys, back to the code. So to start with, we are going to want to figure out how we can turn our thought process into code. And the last thing we said was we will need two variables to keep track of the number of opening brackets and the number of closing brackets. So before we do that, let's think about what the return value will be and the approach for this problem. We had previously said that we'll do it recursively, so we will need a helper recursive function. First thing that I usually like to do is figure out the return type. So what we're going to return, in this case, it's a list. So we're going to create an array list of strings. We'll call that results. Okay. The next thing we want to do is our array list will be empty. And if we're given a value of n is equal to 0, then there's no need for us to do any work. So we'll simply check if n is equal to 0. Then we can simply return result. Otherwise, we would call our helper function. I like to create a helper function that we can use recursively that is separate from the main function. That way we have a distinct idea of what each function's role is in our code. So the first thing I will do is we'll just call the function. So let's call it generate helper. From our code, we said it will take in two things. Well, we need two variables. The first one is to keep track of the number of opening brackets, and the second one is to keep track of the number of closing brackets. So initially, both brackets are 0, 0 because we haven't used any. So when we're calling our method, we'll pass in 0 and 0. After our two variables, the next thing we need to consider is we're building the string each time. So we need to pass in an empty string that we can concatenate the opening and closing brackets to. So we'll pass in the empty string. Next thing would be the result, which is our array list where we can add a combination when that combination is done. So we'll just pass in our results. Finally, we need a way to know when we're done creating a possible combination. In this case, we'll pass n into our recursive function so we can compare the number of opening brackets and the number of closed brackets we've used to n. Okay. When we're done, we simply want to return the result. This will be a public void, as it won't return. This will be a void function as it won't return any values. It'll just keep adding to the array list that we passed into it. I'll just copy this guy. The first argument will be the open brackets. The next argument would be the close brackets. Then it would be our current string that we're currently building. Let's call that cur. Next would be the result, which finally int n. Let me adjust this a little. Okay. Well, the first thing we want to do as we're building is to know when we're done. Otherwise, if we don't have a base case or a case where we know we can stop, then we'll keep going on and on and on. So the first thing we want to do is we want to check if the number of opening brackets is equals to n and the number of closing brackets is equals to n. In this case, we know we're completely done. So we would do if the opening brackets is equals to n and the close brackets is equals to n, then we know that we've come to a valid combination using all the openings and all the closings. So we would simply do results.add the current string that we're currently building, and we just return. There's no need to go down. Otherwise, we have two rules. At any point in time, we can use an opening bracket or we can use a closing bracket. We always start with an opening bracket. So we would want to use the opening bracket first, but we can only use an opening bracket if the number of opening brackets we've used is less than n. So we would do if open brackets is less than n, then we can then call this method again and add an opening bracket. So we'll call this. In this case, the number of opening brackets will go up by 1 because we're about to add one. So we'll do opening brackets plus 1. The number of closed brackets would remain the same because we haven't added any. And our current string that we're building would go up by 1. So we'll do cur plus 1 opening bracket. We'll then pass in the results, then we'll now pass in n. Now, this would eventually go in and add opening brackets up till n. Well, when we're done adding all the opening brackets, we now need to close those brackets as we create possible combinations. To do this, we will now use the closing brackets. How do we do this? Well, we can only apply a closing bracket if the number of opening brackets we've used is greater than the number of closing brackets. So we would make an if statement saying if open brackets is greater than close brackets, then and only then can we, sorry, they should go up by 1. They should go up by 1 since we're about to add 1 opening brackets here. And here, this would go up by 1 as well. And we would add a closing bracket here. So going over it again, going over the whole thing one more time, well, we create a result. The result would be what we return. If the input that we have is 0, then there's no need to do any work. We simply return the empty result. Otherwise, we call a helper recursive function that goes through and we pass in the number of opening brackets we've used, the number of closing brackets we've used so far, the current string we're building, the result, and n, which is the number of opening and closing we can use. The first thing we do in our recursive function is to check have we used all the number of opening and closing brackets we can use. If the answer is yes, we simply add it and return. Otherwise, can we use any more open brackets? And we can only do that if the number of open brackets we've used is less than n. If that's the case, we call our function and we add an opening bracket here. But we also make sure that we update the number of opening brackets we have used, passing in the result and n. Same thing with closing. Well, we can only use the closing brackets if the number of opening brackets is greater than the number of closed brackets. And so we do that here. We call the function, we increase the number of closed brackets by 1 and we concatenate, and we concatenate the closing brackets here. Running this, sorry, this should be results. Typo. Running this, we have the proper answer. If you have any questions, feel free to leave them in the comments. I'll try my best to go down there and answer them. If you have problems that you think I should solve or explain, feel free to drop them in the comments as well. If you found this video helpful, feel free to like and subscribe. Thank you very much for watching. Catch you on the next one. Goodbye.